welcome to Science Spectrum with Don. This is the 7th part of the 3rd lecture in measurements of physical quantities. And of course, in the course code PHY 187, the fundamentals of physics. Now in today's class, I will proceed from where we stopped in the previous class, and that is measurement of length. Alright, now there are two ways in which you measure things. The first is direct measurements, and of course the other is the indirect measurements. And of course I would focus more on the direct measurement, but I may give you an inkling of what indirect measurement is all about. Let's say, for instance, how can we measure the distance apart between the Earth and the Sun? Right? We use, of course I can't use any scale. We can't use a scale to measure that, but if you send, let's say, laser light, monochromatic light, right? It has a unique frequency. So when you send laser light and then you mark the time it takes for the laser light to go back and forth, right? And of course, you could easily figure out, since the time for the laser is given, the time it takes the laser to go back and forth is given. And of course, we know the speed of light. The speed of light is 299,792,458 meters per second. So if you know the speed of light, you know the time it takes for the laser light to go back and forth, of course you can measure the distance, because speed is simply distance divided by time. So distance would be the speed multiplied by the time. So this is indirect method. But now I'll focus in today's class on the measurement of length. Now this is length in our laboratory, right? Alright, now length is simply the interval between 2 points in space. Length could be on the straight line, it could be on the curved path. Now, if you want to measure length of, let's say, a book, your biro, your pencil, you want to measure the length of your desk, right? You could use the meter rule. The meter rule is just a scale, right? It's just a scale in centimeter, or it could also be in millimeter, but it's just a scale that goes from 0 to 100. So by the way, 100 centimeter is a meter, so we call this a meter rule. Of course, you're free to call this a centimeter rule or even a millimeter rule. But now, if I take, let's say 1 centimeter on this meter rule, right? And I have 10 marks there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So this 10 marks is in millimeter. So a meter rule, you could have the centimeter up and the millimeter down. The millimeter is the shorter divisions or the markings. So 10 millimeter is just the same as 1 centimeter. A milli is just a prefix, which is 10 raised to the power minus 3. Centi is a prefix, 10 raised to the power minus 2. And the unit for length, SI unit for length is the meter. So definitely 10 times 10 raised to the power minus 3 translates to 10 raised to the power minus 2. That's right how it came about. Now, the meter rule could measure to an accuracy of, now if you look at this scale here, that's the meter rule, or you could call it the millimeter rule. The shortest, right, interval you could go is just 1 millimeter. Is that correct? So the accuracy is 1 millimeter. But of course, I could still look in between, right, the 1 millimeter. So this interval that is in between, though not specific, I could just say this is half of a millimeter. So the accuracy of a meter rule could be 1 millimeter, or you divide it by 2, and that is half of a millimeter. So this is the accuracy of the meter rule. Now, what is accuracy? It's simply the shortest distance, right? The shortest distance on this scale. So accuracy. We also use the word least counts. That's when we deal with instruments, now measuring instruments, or least count is the shortest distance the shortest distance, or we use the word resolution, the shortest distance or resolution on an instrument, And of course, we could see this clearly, that the smallest mark here is 1 millimeter. So for my convenience, I would prefer to talk about the accuracy of a meter rule to be 1 millimeter. But of course, we could see this half of that, that's 0.5 millimeter. All right, now that's for a meter rule, to measure the length of your book, the length of your desk, right? And of course, but what if you want to measure length that goes beyond length of your desk or of your book, length that goes beyond 100 centimeters? Definitely, we use what we call the tape rule. So the tape rule, you could use that to measure dimensions of your room, right? Or even the football field. All right. Now, what if we want to measure intervals, right, along a curve? Let's take, for example, this is an object, right? But I can't really read off what this interval, that this diameter is, right, with a meter rule. So we use instruments like the Vernier caliper or the micrometer screw gauge. So the Vernier caliper, let me start from there. So we want to measure diameters of round objects, we use Vernier caliper. So this is the Vernier caliper, the Vernier caliper. All right. So the Vernier caliper is just an instrument. Is used for measuring. Okay, the inner. We call this, right, the internal, inner or internal, and outer. We also call the outer external, inner or outer diameters of round objects, of round or curved objects, All right, but of course it goes beyond inner and outer diameter. If I want to measure the depth of this hollow in this cover of the marker, I could still use the Vernier caliper. So I may need to draw the Vernier caliper to us, and let's see how it looks like. So this is the Vernier caliper. It looks somewhat like so. This is the Vernier caliper. It looks somewhat like so, right? And of course it has a fixed jaw. So this is a fixed jaw, the other fixed jaw. We'll get to that shortly. And of course, fixed jaw. So I have this. All right. So there is another jaw here, right? There's another jaw. There is another jaw, right? That has a nut, right? A screw here, and of course I could stretch this, right? And of course I could just all right. So let's see how this goes. Now this goes somewhat like so, right? There is a locking screw here. All right. Now this is the locking screw. I could call this locking screw S. So I need to indicate the screw here. This is the screw. This is the screw. The screw, just okay for my convenience. All right, then I have another here, right? Somewhat like so. So this is P. So let me call this jaw A. This is B. This is C, and this is a D. Now there is a scale just like you saw in the meter rule, or your millimeter rule, so to speak, if you like. So that scale is made of a metal, right? It's a metal, so it's a metallic scale, right? So it goes like so. So this is the meter, just a scale, and of course it's graduated in centimeter or millimeter, as you like it. Now there is another scale here. There is another scale here that I can adjust with the help of the locking screw. This scale we call this the Vernier scale. So this is the Vernier scale. While this scale that is fixed, we call this the main scale. This is called the main scale. The main scale. So the Vernier scale slides across the main scale. That's how this works. All right. Okay. So I could also have this. This could stretch to this, right? Then there is a strip. There is a strip. A strip. There is a strip. Okay. And we need to stretch this. Let's say, let the scale be here, right? Okay, I think it's better. It's preferred. I draw the scale here. All right, so this is the main scale. So the Vernier scale, right, slides across it. I think it's better this way, right? And I could adjust the Vernier scale. This is the Vernier scale now. I could adjust this with the help of screw S. So I could adjust it back and forth so it slides across the main scale. All right, it's fine. Then there is a strip here, a metallic strip that enables us to measure an object, right? An object's depth if the object has an hollow. So this is just how the Vernier scale looks like. All right, so how does the Vernier scale work? We'll see that shortly. Now, if I want to measure the outer and inner diameters of an object, let's say for example that I want to measure the outer diameter of this marker, I could just place it in between jaws A and C, right? And I could slide this Vernier scale with the help of the locking screw, right? Until this could be back and forth depending on the size of this object, right? So the moment it is firmly gripped to point A and C, I could easily read off, right, the value, okay, of the diameter. And if I want to know what the inner diameter of this object is, I'll place it inside jaws B and D, right? And of course I could slide, by the help of the screw S, I could slide the Vernier scale back and forth until it is firmly gripped to point B and D, and of course I could read off what the value is. Now the main scale, okay, it's in millimeter, it's in centimeter or millimeter as you like it. But let's see. So this is the main scale. I need to blow that out now. This is the main scale, right? So this is 0. And let me just take 1 centimeter. That is 10 millimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 1 centimeter, which translates to, it's just the same as 10 millimeter, right? And of course, since it's a scale, it goes beyond, right, 1 centimeter. Now, this is what we call the Vernier scale. The Vernier scale is just a scale that slides across the main scale, which is fixed. So this is 9 divisions. This is 9 millimeter on the main scale. I would fit in 10 divisions of the Vernier to 9 divisions on the main scale. So this is the Vernier scale down here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and of course this is 10. So 10 divisions. So 9 divisions, 9 main scale divisions, right? Main scale division translates to 10 Vernier scale division. Now for the sake of time, okay, I need to wrap it up here. So if you're new to the channel, you may want to like, share, and subscribe for more content. Thank you.